Good morning, friends. Welcome to today's Data Analytics Premier session. In this session, we will cover 10 data science interview questions along with their answers. Data science interviews are very different from any other technical interview, and that is mostly because of the nature of the work that a data scientist performs. You may be asked questions anything from statistics, probability, machine learning, data visualization, and some behavioral questions. And the behavioral questions will test you on your personality, your thinking, your critical thinking, and how you may approach a particular business problem. You might be given a case and you may be asked, how will you solve this question, or how will you um, approach this question. You may also be asked to write some code on a whiteboard depending on whether that particular data scientist role needs coding experience. You may be asked to write code in R or Python. You may be asked to solve some numerical questions on whiteboard or pen and paper. So it's a variety of questions that you will be asked. And today's session we will just look at 10 questions, and these are not exhaustive, obviously, and hopefully I will continue to put out these kind of videos in future so that you are always prepared for any data science job interview that you may be appearing in. So let's go ahead and look at the questions that I have here. Question number 1. What are the assumptions for linear regression? A very, very common question in data science interviews, and for good reason. Regression is such an important concept that everyone should know and understand, and they can ask you a number of questions about regression, and just one of them is, what are the assumptions for linear regression? And they will want to know whether you understand this, because even before you apply regression you should know whether the data that you have can be used for a regression analysis, right? So it should be able to know what are the assumptions. So here I have 4 assumptions. That the data should have a linear relationship, which is pretty obvious because it's linear regression. You cannot apply it on non-linear data just as is. And there should be multivariate normality. The residuals should be normally distributed. There should be no or little multicollinearity, that is, there should not be any high correlation between the independent variables. And then homoscedasticity, that there should not be unequal variance in the data. And when you give these assumptions, be ready to be asked further questions to explain each assumption. So don't just by heart these assumptions and forget the rest of it, but rather go deeper into why these assumptions are there and how they may impact if they don't work properly. So be ready to answer further questions on these topics. The next question I have here is, what is the difference between precision and accuracy, and can you explain in terms of confusion matrix and confidence interval? So in this question you are being asked two very basic statistics concept, that is precision and accuracy, and then you are also asked to explain them in terms of two other concepts, that are confusion matrix and confidence interval. So it tests you on a number of things. So let's look at the answer. Now if you are ever asked what is precision and what is accuracy and what's the difference between them, the best thing is to use the whiteboard and draw a graph similar to the one here and then explain it. It is very easy to explain this visually rather than with the help of any definitions. On here, the first circle is low accuracy and low precision, which means that not only are these points far away from this target, which is in red color, but they're also far away from each other. In the next one, we have high accuracy but low precision. So these points are pretty close to the target, but they are still farther away from each other. Then on the one here at the top, we have high precision. So the points are very close to each other, but they have low accuracy because they are far away from the target. And then on the last one here, it's high precision as well as high accuracy. So not only are the points close to each other, but they are bang on the target, right? So you can use a graph like this to explain precision and accuracy and what is the difference between them. And then if you are asked to explain that in confusion matrix, you can even go ahead and draw the confusion matrix on the whiteboard. I have another video for that. You can go and take a look at it. And then from there, you can define what is accuracy and what is precision. And then finally, in case of confidence interval, you can give an example and you can say that 95% confidence interval is more precise because it is a narrow confidence interval as compared to 99% confidence interval, which is going to be more accurate because this interval being wider would have a higher probability of containing the population parameter for which we are calculating the confidence interval. So you can uh, take all these different statistical and machine learning concepts and put them together and show how they are related to each other and explain it on a whiteboard. I would say that's the best way to answer a question like this. Then coming to question 3. So I have this question in my normal distribution presentation also. You can go and take a look at it. There are a number of other normal distribution related questions there. But let's look at what is this question. So in a test, students in section A scored with a mean of 75 and standard deviation of 10, while students in section B scored with a mean of 80 and standard deviation of 12. Melissa from section A and Ryan from section B both have scored 90 in this test. Who had a better performance in this test as compared to their classmates? A very classic question because as a data scientist, you might be given problems where you have to compare your organization's performance with that of a competitor and tell whether you have done better or worse or the same, right? So instead of a company, here we have two sections in a school and we are comparing their scores of two particular students. So both of them have scored 90, but does that mean both of them have scored equally well or one of them has scored better? So how do we answer this kind of a question? So this question tests you whether you know a normal distribution, whether you know about standardization of data. And to answer this question, you have to calculate their standardized score, which would be the z-score in this case. So what that does, it brings both the scores onto a same scale of standard deviation. So you are then able to compare their scores and tell whether one of them has scored better than the other. So to calculate Melissa's z-score, you have to do x minus mu by sigma. X is her score 90, mu and sigma already we have been given 70 and 10. So we just put it in the formula for z-score and we arrive at the number of 1.5. And for Ryan, again, the same thing, x minus mu by sigma. We have all the values, so we just go and plug them in the formula for z-score and we get a score of 0.83. So even if both of them have scored 90, it's actually Melissa who has performed better than her classmates as compared to Ryan, right? So this is how you can standardize scores. In real life, it may not be this straightforward, but you should definitely know about standardization of data and be able to explain it and expect other questions also on standardization. But this is a very common question. So that brings us to question number 4, which is what is power of a hypothesis test and why is it important? Now, hypothesis test is one of the most important concepts in statistics, and you may be asked a number of questions related to it. For example, what is null hypothesis, alternative hypothesis, p value, statistical significance, type 1 and type 2 errors, and one of such questions is what is the power of a hypothesis test. So the probability of not committing a type 2 error is called the power of a hypothesis test. Now, whenever we are performing a hypothesis test, we obviously don't want to have any error, or at least minimize the probability of either committing a type 1 or a type 2 error. So power of a hypothesis test is related to the type 2 error. We have to remember that, significance level is related to type 1 error, but power of a hypothesis test is related to type 2 error, and the probability of not committing type 2 error is called the power of a hypothesis test. And we all know what is type 2 error, so that is rejecting the alternate hypothesis when it is actually true. For example, calling a guilty person innocent, or diagnosing a cancer infected person as healthy, or a pregnant woman as not pregnant. The higher probability we have of not committing a type 2 error, the better is our hypothesis test. So make sure to revise all your hypothesis testing concepts, because you may be asked any of the ones that I spoke about. And that brings us to question number 5, which is, what is the difference between k nearest neighbors and k means? And it's again a common question, and it is asked because it's easy to get confused between knn and k means, because both of them have the letter k in their names. So KNN, or K nearest neighbor, is a classification algorithm, while K means is a clustering technique. KNN is a supervised algorithm, while K means is unsupervised. In KNN, the prediction of a test sample is based on the similarity of its features to its neighbors. The similarity is computed based on a measure such as Euclidean distance. K here refers to number of neighbors with whom the similarity is being compared. K means is a process of defining clusters or groups around predefined centroids based on similarity of each data point to the other. K here refers to number of centroids around which each cluster will be defined. So make sure to revise all the different machine learning algorithms, and especially comparing them with each other, knowing which one is supervised, which one is unsupervised, which one is classification, which one is clustering, and be able to give a small explanation of what each algorithm does. And the next question is, explain random forest in layman terms. So I have chosen random forest. You could be asked any statistical concept or machine learning concept, and the main thing here is to be able to explain it in layman terms. And the reason for that is, as a data scientist, communication is going to be one of your most important skills, and you might be needed to communicate your algorithms or other analysis that you do to a non-technical audience. So you should be able to relate and associate your technical terms, your machine learning and statistical terms, to day-to-day life situations, and be able to communicate them very easily in a way that anyone can understand them. So practice explaining any concept. Just pick up any concept and try to explain it by using our day-to-day real life, some easy examples, right? So here, asking about random forest, I heard, is very common. You may be asked anything else like p-value. So let's look at what is random forest. So random forest is a supervised tree-based machine learning algorithm, right? We have other tree-based algorithms like decision tree also, that uses an ensemble of decision trees, and random selection of features to reduce the error in prediction. Right? So this is just something I wrote, but you can look at the proper definition in a book. But like I said, be prepared to explain each machine learning algorithm using 2 or 3 sentences if you are asked about them. And here I have one example to explain random forest in layman terms, but you can come up with your own example. So let's look at what is this example. So let's say you have received 3 job offers and you want to make a decision on which job to accept. There are a number of features or parameters or conditions on which your decision is based, such as brand name, employee satisfaction, compensation, growth opportunities, travel opportunities, support for higher education, culture, mission, involvement in charity, maternity leaves, health insurance and benefits, technology, team members. So there are a lot of these variables that are associated with each of the job offers, and you want to find out now, based on all of these things, which one is the best one for you. So you reach out to 10 of your LinkedIn contacts and quiz them about the 3 companies, and every time you choose a random set of 3 features out of all these features that I just said. You only pick 3 features and you ask one contact out of the 10 contacts only about those 3 features. So when you go to let's say contact number 1, you ask them, hey, based on brand name, employee satisfaction and compensation, which one out of these 3 jobs do you think is the best, right? And then you go to the next person and you ask, hey, based on growth opportunities, travel opportunities and support for higher education, which out of these 3 jobs do you think I should go for? And then you go to contact number 3 and you ask them about, okay, based on involvement in charity, maternity leaves and health insurance, which company do you think is the best? So each one of them, the 10 different LinkedIn contacts will give you one recommendation, right? And then finally, the company which gets the most number of recommendation will be your final choice, right? So this is how a random forest algorithm can be translated into a layman term or a day-to-day usage that we all of us do, isn't it? I mean, when we have a job offer or 2 job offers, we look at all these different features, we ask our friends, and we try to take a decision. So you can use this example or you can come up with your own example. The next question is, what is k-fold cross validation and why do we use it? Now, k-fold cross validation is related to other concepts such as overfitting. You may be asked, what is overfitting, what is underfitting, and how can you avoid overfitting? And one of the things you can say that, okay, I can use cross validation. So they can ask you then, okay, can you talk about what is k-fold cross validation? So in k-fold cross validation, we divide our entire data into k groups. For example, in this case, we have divided our data into 5 groups. So if we look here, so I have 5 groups here, and one of them is my validation set, while the remaining are my training sets. And I repeat it multiple times. I choose a different validation set each time and I train and test my data accordingly. And for each of these groups, I take then the average of the outcome and I come up with my final outcome or my final accuracy, right? So that's how a k-fold cross validation works, and it helps us to minimize overfitting. It helps us to minimize any biases and errors in our data, and it allows us to use if we have less data, but even in that case it helps us to perform a good fitting on our data. The next question is, explain how can we handle missing values in our data. So, as a data scientist, you may come across data that is very unclean, lot of missing data, and you should know how to handle missing data if that happens, right? So, that's why you might be asked this question. So, the first thing that you can do if your data record in your data has very little real data and most of it is missing, it is better to just not include that record at all in your analysis. Just exclude it, just delete it, because it is so low quality, it is going to affect your analysis in a negative way. So instead of taking a record which has very less data, it's just better to exclude it, right? Sometimes, however, it is possible that, especially in the case if you are collecting customer data and they miss to give out some information to you, either because they made a manual mistake or they just did not answer, you can reach out to them again and you can ask them again and try to gather the data if that is a possibility. If you have done some kind of a survey, you can maybe request them to fill up some of the missing information, so you can try and do that. Otherwise, you can try to impute the values. You can uh, try to populate the missing data by following a method which could range from just making educated guesses, taking some averages, or through regression, or you can come up with your own way how you want to impute the missing value and populate it in your data. And then you can try out different methods and you can see with which method you are getting the best result, and then select it, because depending on the situation, sometimes just ignoring the data is good, sometimes taking the average is good, so you have to see which one is working best for you and then take a decision based on that. But make sure to revise and go through the different ways in which you can handle missing data, and also how you will handle outliers. That's another associated question that you may be asked. How can you handle outliers in your data? So make sure to revise those questions also. Then question number 9. So what is the difference between a bar graph and a histogram? So once again, because you will be doing a lot of visualization with your data, you may be asked some question about data visualization. It could be about best practices, or it could be asking you about which graph to use under what situation, or just to ask you difference between the graphs. So if someone asks you what is the difference between bar graph and histogram, because they look so similar, the first point you should say is that bar graph is used for discrete data while histogram is used for continuous data. And in bar graph, there is a space between the bars, while there is no space between bars in a histogram. And that's because histogram is a continuous scale, so there is no gap between the bars. And in a bar graph, the order of the bars can be changed and sorted. For example, on this picture, we have the bars ordered in China, USA, France, UK, India, but we can change this order, based on some conditions. But for histogram, it is always the same order, it's either going to be um, from the smallest to the largest, which is how I have always seen them. But maybe you can change it to be from the largest to the smallest, but that's pretty much the sorting that you can do. You cannot do it on any other criteria. So these are some differences. If you have any other that you want to add to it, feel free. Once again, if there is an opportunity to use the whiteboard to explain this, go ahead and use it. And that brings us to the last question, which is what is a box and whisker plot and when should we use it? Right? Be sure to go over all the different important types of graphs. Box and whisker plot definitely is one of the important type of graphs that you should know about. but make sure to go over the rest of them, like things like word cloud, heat maps, bar graphs, pie charts. Make sure to revise what each of them do. You can be asked questions on any of them. So a box and whisker plot helps us to understand the spread of our data. We can represent the maximum, minimum, median, first quartile, third quartile, outliers, right? In my descriptive statistics video, I have spoken at length about the different types of parameters using which we can describe our data. Definitely maximum, minimum, median, first quartile, third quartile, interquartile range. I've covered all of those things in that. So, and one of the important things that box and whisker plot helps us to find out is outliers. It's one of the maybe couple of plots. One I think is the scatter plot, and one is box and whisker plot, which help us to find the outliers in our data. So be sure to know how to interpret a box and whisker plot. This is one plot where instead of the mean we have the median. So you should be able to understand it, you should be able to explain it to them. And that brings us to the end of all the 10 questions that I wanted to cover. Thank you so much for watching this video, and I am going to make more videos on interview questions as time goes on. But don't forget to subscribe to our YouTube channel, follow us on Facebook, and let us know if you have any comments or if you have any suggestions on what videos I should be making. And keep following us, and we will bring you a lot of content as we move forward. The coming Sunday, the topic would be multiple regression, because we did not do that yet. So look forward to that video. And until then, I wish you all the best for your interviews. Prepare well, make sure that you perform well in the interview, that you communicate well. Don't ignore that part. So okay, so that was all. Thank you so much, and goodbye.